Assalamualaikum warahmatullahi wabarakatuh. Today we would like to present about typical reinforced concrete construction. Before we started our presentation, I would like to introduce our team members. There are 5 people that contribute in our group. First is Ahmad Mohsin, second is Muhammad Haziq, third is Nur Aida, fourth is Nur Diana, and the last one is Nur Arisa. I would like to start the presentation with the introduction. A popular building material known for its strength and adaptability is reinforced concrete. It is perfect for many structural applications because it combines the tensile strength of steel with the compressive strength of concrete. In this composite material, the concrete has steel bar or mesh inserted in it to increase its tensile strength, allowing structures to bear heavy loads and stress. Together, these two elements provide reinforced concrete building that are long-lasting, weather-resistant, and able to cover large distance without experiencing undue distortion. Reinforced concrete is a monument to contemporary engineering's capacity to maximize the quality of its component material for safe and effective construction, as shown in the bridge, building, dams, and foundation it has been used.
Hi and Assalamualaikum, my name is Narisa and I'm going to explain about the background detail of the building. We have selected Klinik Kesihatan Jenis Semenyih as the high-rise building for our case study report. Completely formed in 2025, it took place in the complex space in Semenyih, Selangor. This building goals is to improve the community's general health by offering easily and accessible and reasonably priced healthcare services. The current Klinik Kesihatan Jenis Semenyih project is a replacement for the long-running Pure Klinik Kesihatan Semenyih. The main reason to tear down and rebuild a new one on its place is to improve the infrastructure and modifying the size of the building, as it is likely to have increased rate of patients. The demolition of the previous Klinik Kesihatan Semenyih took approximately 3 weeks. The construction project commenced on August 24, 2022, and the expected completion date for the entire construction project is February 18, 2035. This indicates a construction period of approximately 2 years and 5 months. The total cost of the construction project is stated as RM36,407,000. Atlantis Construction Sdn Bhd has been appointed as the main contractor for the construction project by Jabatan Kerja Raya Kuala Lumpur. The contract period for the construction project is specified as 130 weeks. This building has 4 floors. The first floor is for the emergency unit, pharmacy and outpatient area. The second floor is for medical rooms and the staff area. The third floor space is for maternal and child health services and pathology lab. Lastly, the fourth floor serves rehabilitation and oral health. Porcelain tiles, vinyl walls cover and automatic and hermetic door is all contribute to creating a space that is both practical and well suited for medical purposes due to the consideration of safety, durability and functionality tailored to the specific needs of a healthcare environment. The project involved multiple parties, each with specific role in different stages of the building's life cycle. It is include JKR Kuala Lumpur as a developer, HA Architect as an architect, CQE Engineering as a structure engineer, and BEQ as consultant as a quantity surveyors.
Assalamualaikum. Now we move to constructional details. Firstly, we start with foundation. The type of foundation that used in this construction project is pad foundation. The pad foundation was chosen because it helps to distribute all the loads carried from the structure above to the frame to the ground evenly. Pad foundation was also chosen because this foundation is common in this type of building, which is large purpose built structure or high-rise building. Typically, pad foundation consists of a concrete pad or block and are positioned to transmit points loads from frame or column buildings. Without exceeding the concrete bearing pressure, the concentrated load imposed from the columns can be dispersed through the base plate to the footing. The base plate acts as a stand as well as the connector to the column. It connects with pad footing by bolt connection using the cast-in anchor bolt, even though Pad footing is shallow type of foundation. It can withstand loads and stress, distribute to the building and give a high degree of stability. Next, we move to floors. The two main forms of ground floors are suspended floor and ground supported concrete slab. The ground floor's function includes supporting the weight of people and equipment, preventing groundwater intrusion, limiting heat loss through the floor to the ground, and offering a flat, smooth surface for the chosen finish. This concept selects concrete ground support floors as the type of floor for this project because they can withstand the weight of both people and machineries at this building. The flooring for this project was finished with concrete. Concrete floors were chosen for this project because of their exceptional quality, dependability, and cost to quality flexibility. According to the case study we report, According to the case study report we prepared, walls that used for this project is non-load bearing walls, and brick walls were used as wall finishes. Concrete cast in situ has been used to construct the walls. There is no prefabrication procedure involved with cast in situ concrete. It is cast into mold on the construction site. It gives the designer an infinite number of options for any shape construction and a vast array of surface texture. In general, in situ construction techniques are more labor and time intensive, but they are also more adaptable to site change. As we all know, this project includes a clinic in one location. According to the contractor, the steel beam is used for the inside in the building, while the roof is using reinforced concrete flat roof. They provide a sleek modern aesthetic and can be more energy efficient with the installation of reflective materials to reduce heat absorptions. However, proper drainage and waterproofing are crucial consideration to prevent issues like water pooling and leaks. So it's very considered for this building. That's all.
Assalamualaikum. It's Nurul Aida binti Mansur, and I will present about the construction process of the reinforced concrete building. Firstly, estimation of materials. To make the excellent quality of concrete, the proportion of concrete ingredients should be measured properly and accurately. Second, site preparation. The construction process begins with site preparation, including clearing the area, excavating to the required depth, and leveling the ground. This phase also involves marking the layout of the building and establishing reference points. Third, excavation. Excavation is the first step in soil preparation for concrete works. Depending upon the type of structure, excavation is carried out. Fourth, foundation construction. The foundation is crucial for providing stability and supporting the entire structure. Depending on the soil conditions and structural requirements, foundation may be shallow, such as strip or slab foundation, or deep, such as pile or pier foundation. Fifth, formwork installation. Once the foundation is in place, formwork is set up to clear the molds for concrete placement. 6. Reinforcement placement. Reinforcement shall be accurately placed and adequately support before concrete is placed and shall be secured against displacement. Reinforcement should be placed as shown on the placing drawings. 7. Concrete mixing. A concrete is said to be well mixed if it fulfills the following requirement. The concrete mix should be uniform in color, should be achieve proper consistency for which it is designed, complete binding of all concrete ingredients, cement paste should cover all the surface of the aggregate. 8. Pouring the concrete. The pouring of concrete can be various methods such as pumping and manual transporting. 9. Finishing of concrete. The most basic type of concrete finish is a smooth surface created through the use of skids and trowel. 10. Curing. Curing is a process of maintaining adequate moisture and temperature levels to allow the concrete to gain strength and durability. 11. Quality control and inspection. Throughout the construction process, quality control measures are implemented and inspection are conducted to ensure that the work meets building codes, safety standards, and project specification. Lastly, final inspection and occupancy. Inspections are conducted to ensure that the construction complies with all regulations. Once approval are obtained, the building is ready for occupancy. That's all from me. Thank you.
Next, in the building industry, reinforced concrete has many benefits that make it the material of choice for many kinds of application. These are a few of the main benefits. Strength and durability. Concrete compresses strength and steel tensile strength work together to create a material that can sustain large load and stress while maintaining structural integrity and lifespan. Second is versatility in design. It is possible to mold reinforced concrete into almost any shape or form, which makes it possible to create complex and creative architectural ideas that will be difficult to accomplish with other materials. Next is fire resistant. In contrast to certain other construction materials, reinforced concrete has exceptional fire resistance, preserving its structural integrity and buying crucial time for emergency action and evacuation. The fire resistance also depending on its level. The higher building needs special method to prevent the building from burning. Next one is economic efficiency. When taking into account its long-term performance, low maintenance needs, and durability, reinforced concrete can sometimes be more affordable than substitute material. Compatibility with modern technologies. Modern building technologies like integrated smart technology, advanced insulation system, and renewable energy source can be readily included into reinforced concrete structures, improving the construction overall sustainability and functionality. And the last one is safety and resilience. Because reinforced concrete is so strong, it can withstand a variety of dangers such as collisions, strong winds, and earthquakes. This helps to protect building occupants and reduce the likelihood of structural failure. And the next one is the disadvantage of the reinforced concrete. Although reinforced concrete is well known for having many benefits, there are certain drawbacks and difficulties with it in the building sector. There are a few of the significant drawbacks. First is defect and cracking. Even though reinforced concrete is strong, it can break over time as a result of temperature changes, applied loads, and shrinkage. The structural integrity may be jeopardized by cracks, which need to upkeep or repair monthly. Longevity and maintenance. Even while reinforced concrete structures are often long-lasting, they may need extensive upkeep over time, especially when it comes to preventing corrosion in the steel reinforcement and treating possible concrete deterioration. Environmental impact. The energy-intensive process of producing cement, the main ingredient in concrete, increase carbon dioxide emissions, which may have an impact on the environment. Furthermore, there may be social and environmental effects from the mining of raw mineral used to make concrete. And the next one is formwork requirements. In order to mold and support reinforced concrete until it reaches the necessary strength, complex formwork systems are frequently needed throughout the casting process. Formwork design, installation, and removal can increase a building project completion, duration, and expense. The next one is structural complexity. For reinforced concrete structure to function structurally and be safe, the integration of several components such as steel reinforcement, formwork, and concrete requires careful detailing, quality control, and expert labor. And the last one is weight. Because reinforced concrete construction are often heavy, they may require larger foundation and more structural support. The handling and transfer of this extra weight during construction may also be impacted.
Okay, next is plant and machinery. The construction of a reinforced concrete building involves various plant and machinery to ensure the efficient and precise execution of a different task. Here are some of the plant and machinery commonly used in the construction of reinforced concrete building. Okay, first is excavator. Excavator are very commonly used for the excavation of the building site to create a foundation for the structure. Uh, they are they are very essential for digging trenches, removing soil, and shaping the terrains. Okay, next is concrete mixer. For the concrete mixer, they are used for mix cement, sand, gravel, and water to create concrete. This machinery uh, ensure a consistent and homogeneous mix that meet the structure requirement of reinforced concrete elements. Okay, for the third is concrete pump. Concrete pump are enjoy to transport liquid concrete to the construction site, particularly for elevated structure. They provide a more efficient and precise method of delivering concrete compared to the traditional method. Next is tower crane. Tower crane are very commonly used in the construction of reinforced concrete building. They always lift heavy materials such as steel reinforced and concrete to different level of the building. Tower crane are very essential for the construction for the high-rise structure. Next is rebar cutter and bender. Reinforcement bar, or we call rebar, critical component in reinforced concrete construction. Rebar cutter and bender are very used to cut and shape steel reinforcement according to the structural design. Next is concrete finishing equipment. Equipment such as power floats and troweling machine are used for finishing concrete surfaces. They contribute to achieve the denser texture and smoothness of floor and wall. Uh, Next is trowel and screed. Trowel and screed are very used to finish and level the surface of freshly poured the concrete. This is to ensure a smooth and even surface for roof flooring and other finishing touches. Uh, Next is concrete vibrator. Concrete vibrator are very used to remove all the bubble or the air bubble and ensure the proper compaction of concrete during the pouring process. This is very hard in achieve a dense and strong concrete structure. Last but not least, for concrete testing equipment. Various testing equipment, including comprehensive strength testing machine and non-destructive testing loads, are used to ensure the quality and durability of the concrete used in the construction. Okay, to make a conclusion, reinforced concrete is very widely used in Malaysia construction industry because it's strong and cost effective. It's very known for being sturdy and affordable, making it a practical choice for various projects like foundation and wall. In the case of the Klinik Kesihatan Jenis Semenyih healthcare facility in Selangor, reinforced concrete is chosen for its ability to meet the building structural needs. This makes it a crucial material in creating essential infrastructure like healthcare facilities that benefit local community. So for overall, reinforced concrete is a key player in modern construction, offering a reliable and budget-friendly solution for different structure. That's all. Thank you.